Good morning, algebra students. Hope you had a great weekend. Just wanted to finish the 5.6 notes with you, which we got started on Friday. Remember, we're talking about scatter plots, lines of best fit, possible trend lines, and making predictions for the future based off of given data. So I do believe we left off and are ready for example number 4, writing equations of lines of best fit, also known as trend lines. So step 1 is to identify 2 points on the trend line. Choose points that will be easy to use, such as whole number values. Remember, the points don't actually have to be data items. They can be any 2 points on the line. So the ones that they recommended you to use in this problem were 220 and 640. So use your slope formula, y2 minus y1 over x2 minus x1 in order to find your slope. So 40 minus 20 over 6 minus 2 is 20 divided by 4, which is 5. So 5 is the slope. What else do we need? We need the y-intercept. So the y-intercept in this problem is 10. Put it all together, y equals 5x plus 10 would be the equation of this line. Does that seem reasonable? Yes, it does. You got your y-intercept of 10, it's a positive slope, it's cutting through the middle of the data as best you can. Now, if needed, we could use this trend line or the equation to make predictions based off, well, what would it be like for 20 people? Or how much would it cost for 50 people by plugging in those values for x? But for now, we have our equation. Moving on to the next example right after number 4, which I forgot to number as 5, find the equation for this trend line. Again, find 2 points on the line. They don't have to be the original red dots that came on the graph itself from the original data items. I chose 210 and 7, 25. So over 2 up about 10 I thought was right there, and then over 7 up 25 I felt like was right there. Now, what's great about this, any of you could have chosen 2 different points different than mine, and it would have been completely fine. As long as the slope width is within reason, you're going to be good. So again, I chose 210, 725, and I found the slope. 25 minus 10 is 15, over 7 minus 2 is 5, 15 divided by 5 is 3. So if you chose 2 other points and you get a slope around, 2.5 to 3.5, even 4, probably going to be okay. I looked for my y-intercept, and I said my y-intercept was about 4.5. Some of you may have said 4, some of you may have said 5. That's fine, as long as it's close to what it should be. So putting it all together, I said the equation of this trend line was y equals 3x plus 4.5. Again, y equals 3x plus 4.5. And if you have something close to that, it would absolutely work as well. On to the next example, the real example 5. So on this one, we've been given data and it says to make a scatter plot of the data and then draw a line of best fit, write an equation for the line. So I graphed the points 0, 2, 1, 3.5, 1, 2.5, 2, 3.5, 4, 4, 5, 5, and then 6, 5. Here's the tricky part. Your line may look a little bit different than mine. That's okay, as long as you do your best job to cut through the middle of the data as best you can. Try to have an equal number of points on top as on bottom. So this is what mine looks like. Obviously, like I said, yours could be different. Everyone's line's probably going to be just a little bit different. I could do this again and come up with like 3 different lines. I'm going to choose 2 points to find the slope. I chose this time to use my y-intercept. Yes, I know that actually came from the charter table itself, and that's where I drew my y-intercept to be. Some of you may have y-intercepts that are just slightly up from there. Again, that's fine. So I chose the point 0, 0 and 5, 5. Now I got lucky this time because both of the points I chose were on my line and they were data items. That's not always going to match, and that's fine, as long as the 2 points you choose are 2 points on your line. I found my slope. 5 minus 2 over 5 minus 0 is 3/5, and I said my y-intercept was 2. So y equals 3/5 x plus 2. Done. There's the equation of your line. Again, your slope may be a little bit different. Your y-intercept may be a little bit different. It's okay as long as it's within reason. The last one is where we're actually going to make some predictions. And this one shows the cost of movie tickets. I guess it's not the last one. Sorry, guys. This scatter plot shows the average ticket prices for the movies over several years. The scatter plot suggests a linear association. Yeah, because it's basically make a straight line. It's showing a positive correlation. So find an equation for the trend line. So again, you have to find 2 points on your graph. I chose 8, 7, and 3, 6 from the line. I did 6 minus 7 over 3 minus 8. Good thing they're both negative. So negative divided by negative is positive 1/5 there. And I said the y-intercept was about 5.2. Yours could be a little bit different. That's fine. Put it all together. Y equals 1/5 x plus 5.2. Now, we have some follow-up questions for this one. How much will a movie ticket cost in 2020? Notice these are years since 2000. So 2020 is 20 years past 2000. So I'm going to plug in x equals 20 into the equation that we just came up with. So y equals 1/5 of x, only we're plugging in 20 for 20 years past 2020, or 20 years past 2000 in the year 2020, plus the y-intercept of 5.2. 1/5 of 20 is 4, plus 5.2 is 9.2. It's money, so you better put a 0 at the end and the dollar sign at the beginning. So how much will a movie ticket cost in 2020? About $9.20. Yours may be slightly lower or something higher if you were to do this on your own. Now, the follow-up question to that is, when did the average movie ticket cost $6.50? There's a couple of different ways you can do this, but obviously the easiest is to look at the total price, the ticket price here on the y-axis. Here's $6.50. I'm going to go across from $6.50. Boom, there's my line. I circled it. Where does it meet up? X equals 5. So 5 comma 6.5 would be the point. So x equals 5. Remember, that's years since 2000. So 2000 plus 5 years after would be 2005 is when the average movie ticket costs $6.50. And the last example, grapefruits. On the grapefruit question, they gave us the data. We made a scatter plot. Here it is. I put years since 1997 across the bottom. I put price up the y-axis. And I counted, I kind of spaced it out pretty far. I did 0 and then 1, 2, 3, 4, 5, etc. I don't like these, and if we're not careful, it's going to be really hard to see the y-intercept, but this one was not bad at all. So I did this jig-jag, zigzag, whatever you want to call it. It's called a broken graph, basically. It's letting me jump from 0 up to 50 cents, so we don't have to fill in all of those. And then I can spread these out pretty close together. Not, I guess not spread out, but then I can have enough room to actually see what's going on between 50 cents and 66 cents without them being, right on top of one another. So again, I use that zigzag line there, the broken graph. I graph my point 0.53, 155, 258, 358, 460, and 562. I found my y-intercept. I thought it was a convenient point to use to help find my slope. 0, 5.3. When I drew my line, I tried to do the best I could. This one was a little bit trickier to cut through the middle of the data. So again, 0.53 was one of my points, and I chose 5 point and then comma 6.2, 0.62, sorry. Close enough right there. So I've got 0.53 cents and then 5.62 cents. Found my slope, and I got 0.09 divided by 5. Ladies and gentlemen, do not use that as a slope. That's got a fraction and a decimal in there together. Not going to happen. Since it's a word problem, you can always convert those over to decimals, which is 0.018 or about 0.02. And I already found my y-intercept at 0.53. So y equals 0.02x plus 0.53. There's the equation for the trend line. Now, it says, would it be reasonable to assume that the price of a pound of grapefruit would cost 63 cents in 2005? Well, first of all, look at your graph. I'm basically already at 62 cents already after 5 years since 1997. So no, I don't think that in 2005, which is 8 years past 1997, does it seem reasonable to expect that? And just to double check, I plugged 8 in for x into my equation. Y equals 0.02 times 8 plus 0.53. So 16 cents plus 53 cents is 69 cents. That is too low of a cost, what they had predicted up here. for a pound of grapefruit. 63 cents is a lot lower than obviously 69 cents is. So I said, no, I do not believe it to be reasonable. Okay, the rest of the hour is yours. I should be able to see a completed 5.6 note sheet from you when I return. You have the rest of the hour to work. You need to be working on making sure your 5.5 homework from Friday is complete and your 5.6 worksheet. It would be awesome if you got to class tomorrow and both of these things were done. Some of the ones on the worksheet can be a little bit tricky. Just do your best, and I'm sure you'll do a great job. If you have any questions, feel free to email me.